All right, graphing one more here. F of x equals 1 over the quantity x minus 3 squared. That squaring is not a transformation. That is a comparison to y equals 1 over x squared. All that happens is we're going to shift this to the right 3 units. Because x equals 0 will make the original function that we're comparing to, you'd have 0 in the denominator, and that would be undefined. Now, when we shift right 3, x cannot equal 3 for our domain. We should expect to see a vertical asymptote at x equals 3 then. Now, if I were to put in -3, -2, -1, I know I can't put in 0 here, but that's going to give me something undefined, and I want to make note of that. And then 1, 2, and 3. Before any transformations, we'd have all of these negatives. When squared, you get a positive. It's going to be 1/9, or approximately 0.1. Then 1/4, or 0.25 exactly. 1 over +1, 1. This original will have y-axis symmetry. This is an even function. Squaring all those positives will give us the same result. So 1, 0.25, and 1/9, which is approximately 0.1. Well, we want to have those same y values. There are no vertical changes here. But we need to just shift right 3 units. If you solve for what makes x plus 3 equal -3, subtract 3 from both sides, you would get -6. Sorry, that's x minus 3. So add 3 to both sides. X minus 3 equals -3. Add 3 to both sides, you get 0. It's the same result as shifting this x coordinate 3 units to the right. So do the same to the rest. Now at x equals 3, the function will be undefined. We're going to plot 0, 1/9, 1, 1/4, and 2, 1. That'll be one branch on the side of what I expect to be a vertical asymptote at x equals 3. And then on the other side of the vertical asymptote that I expect to see, plot 4, 1, 5, 1/4, and 6, 1/9. I'll let you take that in for a moment. Here comes the plotting. You can see I've got those 6 points plotted as promised. And when we connect, we are getting x equals 3 is a vertical asymptote. So that will go along with the domain being x not equal to -3. Furthermore, just like in the last example, the degree of the numerator is 1. And if we multiplied out things in the denominator, that would be 2. Whenever the degree, constant, so degree 0, there's no x there. If we multiply out the denominator, you're going to have an x squared in there, nothing higher. Compare degree 0 in the numerator, that's less than degree 2 in the denominator. And so y equals 0 is going to be a horizontal asymptote again. And you can see that that is happening as we go to the far left and the far right. This is flattening out, getting closer and closer to the x-axis from above. So a range is that y is greater than 0. And y equals 0 is the horizontal asymptote. Never are you going to be able to solve 0 equaling this thing. And since the denominator is always going to be non-negative, 1 divided by non-negative is going to give you either the undefined right here or something that is positive. Just letting you have a quick look at that final conclusion. Domain, vertical asymptote, range, horizontal asymptote. And again, you're never going to get a oblique asymptote when the degree of the numerator is less than or when it's equal to the degree of the denominator. You're never going to have both horizontal and oblique at the same time. You have to have the numerator's degree greater than the denominator's degree to get a horizontal asymptote, oblique asymptote, sorry. All right, that's it for now. Hopefully this have helped. If so, please like the videos, subscribe to the channel, and share if you know anybody else that is working on similar material and needs help. Take care, and I'll see you in the next one.